All right, so today we're going to finish up with strings with a couple more exercises and a couple more introductions to processing data because, again, what are strings? Well, we've been playing with toy strings, right? My name, the School of Computing name, and stuff like that. But in reality, what do you use strings for? You use them to hold data, right? And data has some sort of format that you have to process. For example, one common data format that you have to process is CSV data. CSV data stands for comma separated value data. And you've probably seen this before with like a CSV file. If you download a CSV file, what the heck is that? You double click on it in a Windows environment and it opens up in Excel. You've got basically records, which are rows. You've got fields, which are columns of data, right? For example, let's just go ahead and show you an example of CSV data here. Right? That we've got, these things are called tokens, right? And they're separated by, well, like it says, comma, separated value files. So first name, comma, last name, comma, NUID, comma, 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 right? These are the header values. Right? In an Excel file, these would be at the top. If it's in a table, then that would be the table header. Each one of these in the row after is a record, right? And each one of those tokens in that record are referred to, are separated by a comma and referred to as a token, right? So again, each item is a record, each row is a record, each item is a token. Splitting up the tokens along each line is referred to as tokenization. So what I want to do is I want to take one of those examples and I want to split it out. I want to cut it up so that I am looking at the first token, the first name, the last name, the third, whatever it is, NUID, et cetera, et cetera. So let's go ahead and take Margaret Hamilton over here and bring her over here and put her into a data string, right? So char data, right, is equal to what we just saw. There we go. I want to tokenize that, okay? So there is this function called strtoke, which stands for str tokenize, right? It's going to tokenize this string. It's going to cut it up into each one of those tokens, okay? So here's how it works, right? The first time you call strtoke, you pass the string you want to, you pass 1, the string you want to tokenize, and 2, the delimiter you want to split it along, right? Example, a comma. It doesn't have to be a comma. You can have TSV files, which are tab separated value files. You can have other files that separate things like by say a colon, for example. Let me go ahead and show you one example here on CSE. I'll increase the size here. Right. More Etsy password. Right. Etsy is short for etc., right? Just miscellaneous stuff. Although there is a miscellaneous directory, right? So don't get it confused with that. We just call it Etsy in the context of Unix. And then there's this file called passwd. What do you think that stands for? The password file. So should we be able to read the password file? Yes, we can. Right? Now, this is legacy. They used to store passwords in these files, and that's why it's called password. All these X's right here are the passwords that have been redacted. The actual passwords are stored in the Etsy shadow file. More Etsy shadow. Right, there we go. There it is. And apparently they've been moving. There's a backup from some other time. There's a backup from this past April. Right. So should we be able to see any of these? Thankfully, no. Permission denied. Right. But if we look at the Etsy password file, it's got tokens as well. And each one of those tokens is delimited by a colon. Right? So this is a common way of representing data in what's called a flat file. It just takes the data and it flattens it out. This is in contrast to a relational database management system that we'll talk about in, say, Computer Science 1 if you're going to take that next semester, right? Where you separate it out into different tables and then you've got relationships between those tables. This is just one big giant file, right? We can find me. Grep me. There we go. There I am. Hey, it's got my correct office number. There's my actual phone number, which I never answer, so don't bother calling. And I just let everything go to the voicemail. Right? And then if I'm lucky enough to remember the password to my voicemail, I'll clear it out every so often. Email, only email. But otherwise, there's my name, there's my home directory, there's my default shell. I think everybody's default shell is going to be TC shell, right? But there's my user number. There's my, 105 is not my office number. That's over here. 105 is my group number, right? Whatever that is, faculty probably, okay? But you can find yourself in the Etsy password file and look and see what I mean, it's not that interesting for a typical student. They'll just put your address as the main CSE office or the SOC office, right? So nothing to worry about there. But it is common to delimit data like that, right? Since we're on this digression, right, there are alternatives, right? If you want, let me go ahead and grab this data and show you what it looks like as a JSON formatted file. Let's go ahead and convert this. JSON stands for JavaScript Object Notation. Right? And if we've got a collection of records here, a collection is nothing more than an array. This is why we have this square bracket right here, an array. Each element or each object is represented with an opening curly bracket, closing curly bracket. Each one is delimited by a comma. Inside we have key value pairs. That the first one, first name maps to Chris, the last name maps to Burke, etc. If you've got a number like an NUID, then you don't have quotes on it. Right? Otherwise, that's a common data interchange format. If you're trying to transmit data from one computer to another computer and you have completely different technologies, right? One of them is running Java on a Unix system and another one's running C# on a Windows system or whatever, you still need to get data back and forth. You need to exchange data in a universal format. CSV files are a universal format. JSON files are a universal format. XML files are a universal format. Right? So here's another way of representing that data. I wouldn't call it root, I would call it persons. Right? And I wouldn't call it a row, I would call it person, one person. And one person. But each one of these has a tag. Instead of a key value pair system, right, you semantically mark things up with these opening and closing tags. Here's the opening tag. Here's the closing tag with the same name, but then a / /. Which one is that? / You're leaning forward, facing right, right? And each one of these, and it's also hierarchical because these things are inside of this tag right here. So this person consists of this data. You can nest things inside of other things, inside of other things, inside of other things. And you can actually have what's called a schema. A schema would actually be a rule for this is valid data only if it contains these things. And then you can validate your XML against that schema so that you can be assured that on the other end, when they translate it into their system, that it is 100% transferable. So these are various ways of representing data in a universal format, okay? The delimiter that we're going to use is a comma. I want to split this up, right? By the way, if you were actually going to do any of this in practice beyond this simple example I'm about to demonstrate, it's really difficult to get it right? Because what if a comma is in your data, right? Like for some reason there's a comma in my name, right? Or it needs to be escaped. Well, okay, if you're going to escape things, what if a / is in your data? Right? Now you need to escape backslashes, right? And et cetera, et cetera. There's a never-ending, not a never-ending, but there's a lot of complex rules that you have to consider if you're going to do this yourself. Don't worry about it. Bring in a library to do it. Especially if you're going to do XML or JSON stuff, bring in a library. There's way too much of a headache to deal with, okay? But otherwise, let's go ahead and tokenize this data. All right, so I'll give it the string that I want to tokenize and the delimiter that I want to use. Note that it's going to be a string. So, as a string. Right. It's in this case, it's a single character, but I'll show you why later on. You can actually add multiple delimiters if you want. Okay. 3. It returns, go to the next line here, returns a pointer to the first token. Right? So we need to capture that value. Char, star, and I'll just call it token. Right? That's going to be our first token for this. And the first token in this case is Margaret. Okay. So let's go ahead and print that out. Printf token is equal to %s and the line, and then we'll print out the token. So if this works, it should print out Margaret because that's going to be the first token in our tokenized string. And it does, it works. Now, every subsequent call for every time every call after the first, you don't pass in the string. Right? Instead pass in null to continue tokenizing the same string. Otherwise, if you pass in a string, it starts over. Right? So if I just give it the same string over and over and over again, it'll never get to the next token, right? Because this string always starts at the capital M Margaret, right? So tokenize, 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 you'll just get Margaret, 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 Margaret. Right? So what you need to do is you need to make another call to this, capturing the token value, strtoke, on null, with, we'll just go ahead and go with the same delimiter here, okay? Let's print it out again. The second token here would be Hamilton, okay? Famous computer scientist, all right? There we go. I think she's responsible for coining the term software engineering, right? She worked on the Apollo mission. I don't know which Apollo. There are several Apollo missions, whichever one, right? Anyway, let's go ahead and get the second token, the third token, the fourth token, the fifth token. How many tokens were there? 1, 2, 3, 4, 5, 6. Let's see if I got them all. And there we go. She, for some reason, she's in short too. I just copied my office there, right? I got them all, right? What if I went for one more token here? Are there any more tokens to give you? Lincoln, Nebraska, 501 Shore, and then after that, are there any more tokens? So what do you think happens when I try to get the next token? It returns null. The only thing that it can. If something returns a pointer, right, the only way that it can communicate I'm done, or there was an error, or I was not able to do what you asked me to, was by giving you back null. malloc, if you ask for too much space, it gives you back null. Right? The error handling that we've done so far, you give me null and you want me to operate on that? No way. That would be a segmentation fault. I'll go ahead and return with a null value, right? I'm done. Here's now I'm strtoke. Tokenize, tokenize, tokenize. There are no more tokens. I can't give you anything. The only thing I can give you is nothing, and in the context of a pointer, nothing is null. Right? Excellent. So, should I be going about this by copy, paste, copy, paste, copy, paste, copy, paste? Probably not. Instead, what should I be doing? Okay. I could do a for loop if I expect exactly 6 tokens and 1, 2, 3, 4, 5, 6, right? What if there are only 5 tokens? What if there are 7 tokens, right? What if there are 0 tokens, right? So there is a way of doing error handling. If I was expecting a certain number of tokens, I would do it with a for loop, being careful to check. If I have fewer number of tokens than I expected, if I have greater number of tokens than I expected, I probably want to do some error handling in some way, right? This is invalid data, right? And print something out or something, right? So I don't know how many tokens I'm going to have up front, so I'll go ahead and go with a while loop. While the token is not null, right, you still have tokens to read. So print out the token, and I'll take that away from the first print, right? That'll print out the first token, and then calling strtoke again sets me up for the next iteration of this while loop, okay? Now, I'm only going to read exactly the number of tokens that are there. Right? GCC. Right? This is future proof. If I add, I don't know, USA, right, then it'll still work with another token. Now, I'm going to come back here and mention that, again, you can use tokens, you can use a delimiter other than commas. For example, what if I delimited with a lowercase a instead? Right? Doing it on both of these. In fact, you can switch tokens. I want to start tokenizing on commas, but then in the middle of it, for some reason, whatever, I'll switch it to semicolons. And then for another reason, I'll switch it to colons or something like that. If you have very complex flat files, you can do that, but I'm going to keep it like this. Right? So all of the lowercase a's are tokens now. So what is the first token? Capital M. Then we see a lowercase a. RG is another token. And then we see another lowercase a. RE, blah, 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 up until the next capital A. Right? And those are our tokens now. M, RG, all the way to the capital H. And then the rest of it, because there are no other lowercase a's. Right? No, I meant lowercase a's or uppercase a's. There aren't any. So let's go with uppercase L's and uppercase L's. Right? There's only one uppercase L here. So this will end up getting split on that, and I'll have one more token. There. Hamilton, then it axed out the L and gave me the other token. Right? You can split it along numbers. 1. Right? There are 2 1s in there, so those become... Oh, actually, I need to do it for both. There we go. There. Now, the 105 shore, that became a token too. Why you would do something weird like this, I don't know. I'm just showing you how it works. Right? Again, you generally want to keep it as just a colon or tab or a semicolon or colon or something like that. Okay? Now, I want to bring your attention to how this actually works. Let's visualize this execution. It's not persnickety about any other library except the standard library for some reason. The one that should be put in by default. Otherwise, everything else is put in for me, like the string library, etc. Right? All right. So let's walk through this code. We set up our data string. There it is, Margaret Hamilton, 1, 2, 3, 4, blah, 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 all the way to the end. Remember that null terminating character at the end. Okay? Next. Right? I've set up my token pointer here. What is it pointing to right now? It should be pointing to... Ooh, why is it not pointing to anything? Oh, weird. Okay. All right, maybe it is persnickety about other libraries. Let's include the string library. Let's include the standard input-output library. And let's get rid of this cruft so that we can see it better. There we go. Why wouldn't you complain about those? Okay, anyway. All right, there's the data. There we go. Now it is actually pointing to the M. That's the first token. Do you notice what... Did it change the string, by the way? Did you notice it? It's really hard to see, but if I go back and forth... A, B, A, B, A, B. What's changing? That comma, that delimiter, right? That's how it tells you that there's this string here, right? Margaret. That it starts out at M, but then it ends at the first null terminating character. Right? So let's go back, forward, restore that. All right. And now when we print it. Now when we tokenize the second one, what happens? That pointer is going to be advanced to beyond the null terminating character to the capital H. Right? And did you notice what happens to that next comma? It also got made into a null terminating character. Next, 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 right? All the way to the end. Right? So the takeaway from this is this function going to screw up with your data? Screw your data up, right? So man, strtoke. There we go. Muck up your data is what I meant, right? So let's take a look at the signature here. I see a const on one of those things, the delimiter. It's not going to change your delimiter. There's no need to change your delimiter. But there is no const keyword on the string data that you gave it. What is that screaming out to you? The lack of a const keyword communicates just as much information as a const keyword being in there. It says, yeah, I am going to change your string. I am going to change your data. Right? What if we don't want that? We need to make a copy. What kind of a copy do we need to make? Deep copy. Right? And we've seen how to do that before. Okay? But otherwise, understand that it will change your data. In fact, if I print out my data at the end, printf, my data is now, I'll go ahead and surround it with pipes here, and I'll print out data. Right? My data now is just going to be what? Guess. guess from the visualization. What does data look like now? Margaret, and then it ends with a null terminating character. That's all that's going to get printed out now, right? My data is now just Margaret. So if you want to tokenize something, great. You may want to create a deep copy before you go about tokenizing it. Don't use tokenization for the split length function, right? You are overcomplicating things if you are doing that. Besides, there's no delimiter, right? If you want a length split of 3, 3, 3, 3, 3, it's just splitting along based on a length 3 or 4 or 5 or something like that. There's no delimiter involved. This is the wrong tool for that. Okay. Otherwise, I'll go ahead and put this into the notes so that you have it. Let's see. There we go. And we went through these already, and they're embedded within the code. But you provide two arguments: the string that you want to tokenize and the delimiter that you want to tokenize on. The first call you provide the string. Each subsequent call you provide null to continue tokenizing the same string. Because if you switch to another string, then it'll start tokenizing on that string. Right? Let's see. The return value can be used to determine if you are at the end of the string. When you're at the end of it, it returns null. And that's how you know that you're done. Okay? All right. Questions so far on any string stuff? Or do we want to do, we've got plenty of time, more exercises or something. I don't know. I was writing down ideas for exam 2. And so anything that I do today will not be on the exam. Let's see, what were my ideas? Oh, there's a good one. I think I've done this before. Let's write a function to do alt caps. Right? So what are alt caps? Right. SpongeBob alt cap meme. You've seen it before probably. I don't know. Hopefully something appropriate comes up. This one right here, right? When he's being an idiot and sarcastic about it, he says something like this. It's always in alt caps. So for example, I can say SpongeBob meme. I can translate that into alt caps where I go SPONGEBOB. Keep the MEME. There we go. Alternating caps, right? So do we want to start with a capital or do we want to start with a lowercase? Lowercase? All right. So now you're going to make me type it all again. SPONGEBOB and then MEME. Yeah, that does look better, right? It looks stupider because if the first one is capitalized, you think, okay, well, that's not a mistake, right? There we go. So this function creates a new string that is the alternating capitals, yeah, capitals, right? Caps. I don't know how to spell it, so we won't spell it. Alternating cap version of the given string. For example, right? If the input is SpongeBob meme, then we'll go ahead and output or create a new string that says SpongeBob meme. Right? So if I'm creating a new string here, we'll go ahead and return a new string. Then of course we'll take a string, but we're not making changes to it, so const char star s. Right. All right. Ideas first. Is there a tool? Well, first of all, let's write a test-driven development. Let's go ahead and write our test case here. Char test string is equal to SpongeBob meme. Char expected output should be this one right here. Right? And what I'll do is I'll call alt caps on actual output, alt caps on my test string, right? And then I'll make a question. is the expected output equal to the actual output. Right? How do I do that with strings? How do I compare the contents of two strings? str, cmp. Right? So if the expected output is the same as the actual output, guess what? It passes. And how do I test for that? If the value is, remember, something negative, something positive, or 0 if they're equal. So I'll test for 0 right here. Right? If those are the same, then I'll go ahead and output that it passes. Printf pass, end the line. Otherwise, if it fails, then I'll printf failed expected %s, and I'm going to surround that with, say, quotes or pipes or whatever, so that I know that is there an extraneous end line character, or is there an extraneous space in there or something like that. I expected this, but received %s, surrounded in double quotes, this. Right? Try again. Expected output and actual output. There we go. And because because I want to make sure that I test everything locally as rigorously as possible, I'm going to run valgrind on this. If I ran valgrind, assuming that I had already written this correctly, and assuming that this was all passing already, valgrind would still come out with an error that says you are actually leaking this memory out. Right? So I will also free the actual output. To show you what I'm talking about, I'm going to leave that out for the moment, but we're going to come back to it after we're done. Okay? All right. Does it compile? Yes. Oh, is it actual output, actual output, actual output? Was I not spelling it correctly? Hans char star. Oh, duh. There we go. There we go. Now, of course, it's not going to work. Why? Because it's not returning anything. So expected SpongeBob mean, but received SpongeBob mean. Okay, fine. All right. All right. So help me out. We're going to create a new string, right? A new string that is exactly the same size as the other one. Gee, I wonder if we've done that before. I could start with a what? A deep copy. So I could come back over here and just simply use what I've done already. Right? Deep copy the string, and then change the copy. Right? Yeah, okay, let's do that. Of course, I'll need to cut and paste that because I already erased it. Right? Except that, again, I keep forgetting. What's the first thing I should be doing in every single function? Error handling. If s is equal to null, what should I do? Well, null. Yeah, what's the alt caps version of nothing? It's not. Null. Can't return that, right? Can only return null there. Okay. Char copy is equal to deep string copy of s. Right? So I've got a copy. I've got a copy of this thing right here. I want to go through now in each individual character. I want to flip it to a capital. I want to flip the start by flipping the first one, making sure that that's lowercase. The second one, uppercase. Third one, lowercase, uppercase, lowercase, uppercase, lowercase. So if I've got this mode, right? Flip it to a lower, upper, lower, upper, lower, upper, right? Maybe I want to keep track of that. Which one was the last one that I did? Okay. So I'm going to create a flag variable here, int mode, right? Is equal to, I'll go ahead and go with 0 here. And then I'm going to note in my my notes here of what does 0 mean and what does 1 mean, right? So 0 means make it lowercase, and 1 will end up meaning make it uppercase. Okay? Now eventually I might get rid of that because that's cruft, but you know what? That's good comments right there, right? I mean, because there's really no other way of expressing this unless I can think of a better variable name, right? Convert to lowercase, true or false, right? Well, the false of that is not necessarily uppercase because there are things that are neither uppercase or lowercase, right? Numbers, right? remember that in a second when I show this to you that it won't work and ask you what the bug is. All right? So 0 is going to be make it lowercase. 1 is going to be make it uppercase. That's my mode. For int I equals 0, I is less than strlen of s, or the copy, right? Because now it'll be the same, but I want to work with copy. I plus plus. Right? For each character, what I'll do is if the mode is 0, then I will want to convert that to a lowercase. So copy sub I is going to be, is there a way to convert something to a lowercase? String length, string assignments. I thought we did it, didn't we? Yeah, there we go. Other convenience functions. C-type library. Is it punctuation? Is it space? Is it upper? Is it lower? Can I convert it to upper? Can I convert it to lower? To lower. Of whatever copy sub I is. Do I have to check to see if it's already lowercase? You can, but who cares? Lowercase a converted to lowercase will still stay a lowercase a. Right? Else, copy sub I will be to upper of copy sub I. There we go. Okay. Tupper. And return copy. All right, so there are several bugs. Yeah, go ahead. You see a bug already? Okay. Good. You gave the spoiler, though, man. All right, there we go. SpongeBob meme. I always went with lowercase. Why? Because I never changed the mode. So if I'm going to convert it to lowercase, there, you've converted it to lowercase. The next one that you see, what do you need to do? You need to make sure that you're converting it to uppercase. If you've converted it to uppercase, the next one that you do, you need to make sure that you're converting it to lowercase. Right. There we go. Right. Oh, it passes. Right. It's actually surprising. Why? Because we got lucky. Right. Oh, it passes on mine. I'll go ahead and hand it in. Oh, it fails on 50 test cases. Why? Because I only did one test case. And the grader is doing hundreds or thousands of test cases, right? Your grader is specifically designed to try to break your code. Sometimes that's called fuzzing, right? You give as much bad input, as much wrong input as possible to try to break the code. Intentionally pass null to see if they're doing error checking. Intentionally pass something that's, say, all uppercase. SpongeBob meme. Right? And what should we get out of this? Well, now I've got to go in and change this to what it should properly be. SpongeBobmeme. There we go. GCC. Run this. Okay, what's going on now? Did I type this one correctly, by the way? Tell me if I did or not. Oh, I didn't. Okay, what did I do wrong? B. All right, the rest of this is wrong. O. B. Ha. B. O. B. M. E. M. E. There we go. Right? All right. Okay, now it passes. All right. What if I had, say, 2 spaces in here? What should it be? 2 spaces, okay. So in other words, spacing shouldn't change our structure at all, right? But if I had 1 space, does it change our structure? Oh, well, take out this 1 space right here, sorry. Does it? Oh, no, it works. Darn it. I'm trying to break it. There we go. Yes. SpongeBob meme. SpongeBob meme. Okay. Yeah. It works in the first 4, and then it fails for all the rest. Why?
It's changing the case.
It's case. Yeah. When it sees this, what's it doing? It's going. I'll change it to lowercase, uppercase, lowercase, uppercase, and then the space. It ends up changing that lowercase, and so you're off by 1. Right? So let's come back up here and rethink this. I only want to change it if it's a letter. If it's not a letter, move on. Okay? So one solution would be to surround this entire thing with if copy sub I is a letter, dot, 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 then do all this stuff. I wonder, is there a way of determining whether or not something is a letter? Yep. We didn't write it here, but yeah, it is alpha. So let's read all about it. Man is alpha. There we go. Okay, come on. These functions do a lot of things. There. Is alpha checks for alphabetic characters. The standard is C locale. It is equivalent to is upper or is lower. In some locales, there may be additional characters for which is alpha is true letter. Locales mean other languages, right? So, not even other languages, other like diacritics and stuff like that, like an A with an umlaut over it, right? Is that still a lowercase letter? Yes. But it's not in the ASCII text values. So in a different locale where you're using umlauts or other diacritics, there could be other things that are lowercase. I don't know, do you put diacritics on uppercase letters in some languages? There's that one with an A, and then there's a dot above it, right? Is it like Norwegian or something? Whatever. I don't speak any of those languages, so I don't know. If it's a letter, is alpha is good enough. If it's a letter, then go ahead and go with this process. Otherwise, skip it, move it on. Move on. Right? GCC. Right? And run it. There, now it passes. Except that all those things, other things that I tested and passed, right? Now I've got to go back and rewrite it, make sure that they're pass. What should I have done? I should have left those in here and make sure that it passes everything, right? Which is what you're doing in your tester, right? So, how do you test whether or not the expected output looks like this? This is how you do it. Now you might have a question of, well, wait a second, when I do the length split, I've got an entire array of strings. How do I tell whether or not an array of strings is equivalent to another array of strings? Write a loop, right? Does the first one match? Does the second one match? Does the third one match? Does the fourth one match? Right? And how do you tell if something matches? strcmp. Right? Now let's go ahead and run valgrind on this to see if there are any hidden errors. Right? There's one error, thankfully. It is a memory leak. There are 15 bytes that are lost somewhere. And again, what is that? It's the actual output that is lost. Right? If I free that up at the end of my tester, then I get a clean bill of health from valgrind. Hand it in, you're done. Right? Okay. Any questions? No? If you want to write it a little bit different, pass. I put out more information here if you really want to. Otherwise, a lot of times when I when I do the grader and there are thousands or millions of test cases, I'm not going to print out pass. I'm only going to print out if it fails. If it passes, I'm simply just going to increment a counter, and then at the end, 100%. Right? You don't need to know anything else. Right? You passed all your stuff. Right? Whatever you do, don't output millions and millions and millions of lines of output, because once you hit 135 megabytes, you see that memory exhausted message from the server. Okay. It's another idea that I had. Blanks, remove space. Yeah, this one's way too complicated to do on an exam, so we can talk about it at least, but I don't know if we can do it in 10 minutes. Convert a variable name, a string that represents a variable name in underscore casing to upper camel casing. So for example, if I've got number of students, I should convert this to number of students. So at least let's outline this. All right? So outline. Well, of course, the first thing that you should do is error handling. The second thing that you might want to do is the input validation. You know, I'm promising that I'm going to give you an underscore casing variable name, right? A string that represents that. What if I gave you, say, something with a space in it? Like, no pride out of that, right? You gave me something that you shouldn't have. That's also error handling. If you give me input that is incorrect, if you gave me a bad CSV data, right, and I expect 6 tokens, and you gave me something with 7 tokens, I'm well within my rights to refuse to do anything and say, nope, you handle this because this is wrong. I don't know what to do in this case, right? So if you give me something that is not underscore casing, then let's go ahead and refuse it. So input validation is the string a valid, underscore casing variable. Right? So for example, you'd go through and what's permissible? Lowercase letters and underscores. Right? Anything else? Nope. Done. Don't do anything. That's an easy way of validating it. Not only that, but why would you want to go through it at least once and count up the number of underscores? Number of underscore, right? How does that help you? Also, at the same time, count the number of underscores. Are there any underscores over here in the result? No. That tells you exactly how many characters you're going to cut from it. That tells you exactly the size of your new string should be, right? Whatever the size of the old string is, -2 in this case, because there are 2 underscores in there. Right? Okay. Then what? 2, create space enough for the new string. Right? 3, iterate over each character in the input. Right? Now what should you do? Kind of like alt caps, right? If I'm in a certain mode, go ahead and lowercase it. If I'm in another mode, uppercase it. Lowercase it, uppercase it, lowercase it, uppercase it. Right? So what should I do to start out with? Lowercase, 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 lowercase. Ooh, my first underscore. What should I do? Skip it, go to the next letter, and immediately uppercase it. Right? Now that I'm done with that, continue, lowercase, if there were more, lowercase, 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 until you get to the next underscore. Then go into another mode. The next one, uppercase it. Right? And continue, 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 continue until you get to the end. Right? So iterate over each character in the input. If you see an underscore, right, then go copy the next character as an uppercase letter. Right? Otherwise, just make sure you already did input validation up here, so you know that everything is all lowercase anyway. Otherwise, just copy it, right? Because you wouldn't have gotten to this point if it's a punctuation or if it's a number or if it's a capital letter already, right? Until the end. Right? So it seems pretty straightforward, right? But there are several failure points, and I don't know if we can do it in the next 6 minutes. So I'm just going to leave that as an exercise over the weekend after you get done with your hack. And then another exercise that you can do, is do it the opposite. Right? Go to number of students to underscore casing. Right? Don't worry, I will not. I promise I will not be giving these on the exam. The exam actually will be on strings. The exam's not next week, by the way, right? The exam is on the 11th, right? Which is 2 weeks from now, right? 2 weeks from now, it'll be on strings and file I/O. Okay, so you'll be doing string processing along with file processing. I can guarantee you that these won't be on there though. But otherwise, on Monday we'll start on file I/O, file processing.